Hi, in this series of videos, you are going to learn three important aspects of C# and the .NET framework: attributes, collections, and iterators. Now, you may use some of these things all of the time. For example, there's not a day that goes by where I don't use an array or a list. Do you know the interfaces involved with the .NET framework's vast set of collections? Do you know what a hash set is, or the difference between a stack or queue? Do you know how to take advantage of the classes in the System Collections Object Model namespace? Well, in the following videos, you will learn about the common collections found in the System Collections generic namespace. You know, classes like list of T and linked list of T, dictionary, sorted list, and so on. But you'll also learn about the collections in the System Collections Object Model namespace, like collection of T, binding list of T, observable collection of T, and a few others in that namespace. We'll also look at the concurrent collections for multi-threaded applications, and I'll also teach you how to write enumerators and implement the IEnumerable interface. But before we dive into collections, you'll learn about a very powerful feature called attributes. Now, you may be familiar with how to use attributes, but I will teach you how to write attribute classes, and then you will learn how to use reflection to find them and invoke their special functionality. In order to follow along, you will need a text editor and the .NET compiler. Of course, the easiest way to get both is to just use Visual Studio. If you don't have Visual Studio, you can download a completely free version from visualstudio.com. Just look for the community version, download, and install it. I'm using Visual Studio 2015 in these videos. Now, I assume you are at least familiar with C#. You don't have to be a master, but you do need to understand the basics. You of course need to understand the syntax rules of the language, as well as creating variables, classes, and new object instances. But that's about it. I will teach you everything else you need to know. Attributes seem like a magical feature, because whenever you add an attribute to a class, property, or method, or even an assembly, it just seems like magic happens. And that's not the case. Now, don't get me wrong, there is code that executes behind the scenes that looks for attributes and behaves accordingly. But by themselves, an attribute only adds metadata to your code. Like for example, this is a new console application project, and inside of the program class, let's add another method. Let's do static void, and let's just call this display message, and this will accept a message object that we will then write to the console. So this is a very simple method, and this is probably something that we wouldn't do in a real application. For the sake of this demonstration, it's going to work rather well. So inside of the main method, we will use our display message method, and we will simply display hello world. Now, whenever we compile this code, we're not going to run into any issues, and of course, if we executed it, then we would see our console window and then the phrase hello world. Now let's say that we want to modify the API of this application. And let's pretend that this is a large application, one where we have used this display message method in a variety of different places. But instead of just displaying a message, we want to now display and log a message. So we're going to write a new method called display and log message, and we will once again write our message to the console, but we would also want to log that message as well. So I'm going to add a to-do there. Now, we are on a team of developers, and we want to specify that this display message method, while you can use it for now, this is a deprecated method, and we will eventually remove it from our API. And we can do that by adding an attribute to the display message method. We do that with a pair of square brackets, and then we have the name of the attribute. So in our case, we want to say obsolete. So we have marked this display message method as obsolete, and as you can see, Visual Studio has underlined our use of display message now. And you can see that in IntelliSense, it says that this method is deprecated. So now we don't have to break our code in order to say that this display message method isn't something that you should use. We have simply marked it as obsolete, and now everybody in the team can make the necessary changes. Now, this is the simplest use of an attribute. You simply have the name of the attribute, and this is actually a class. It's called obsolete attribute. we can peek at the definition and we can scroll up and we can see that the class is called obsolete attribute and that it inherits from a class called attribute. Now let's scroll back down and notice that there are three constructors. There's a default constructor, one that accepts a string, and then another that accepts a string and Boolean value. Now, whenever we peeked at the definition of the obsolete attribute, you'll notice that the default constructor was highlighted. That's because whenever you use just the attribute itself, that's using the default constructor. Now, this object is not going to be created simply because we've added an attribute to our display message method. The code that executes behind the scenes that's looking for this obsolete attribute is actually going to be responsible for creating that object. But if we wanted to use one of these other constructors, all we would have to do is add a pair of parentheses after the name of the attribute, and then pass the values that we need to. So for the message, we could say use display and log message, and that could be our message. We could also pass in a Boolean value. So if we pass true, then the compiler is going to throw an error. And we can instantly see that Visual Studio changed the underline for our usage of display message. And if we look at IntelliSense, we see our message use display and log message. So this could be an option for our development team. By setting the second parameter to true, that will force the other developers to change the code so that they have to come in and change this from display message to display and log message. Now, depending upon the attribute itself, we can also set some values using named parameters. What we've used for the obsolete class are called positional parameters. That's because they are positioned. The first parameter is a string. The second, if we choose to use that constructor, is a Boolean value. But there are some that allow us to set values for properties using named parameters. So let's create a new class so that we can see this in use. And let's call this person. And we're going to add two properties. The first is going to be a string called first name, and then the second is going to be for the last name. And this is going to be a class that we would like to serialize into XML. Now, we don't actually have to do anything to this class in order to serialize it into XML. It will simply create a person element, and it would have two child elements, one called first name, the second called last name. But we want to change that behavior. We want first name and last name to actually be attributes to the person element. And we can do that by decorating these two properties with the XML attribute. This resides within System XML serialization. And we could just use XML attributes as so. However, we want to use custom attribute names because this is going to create two attributes that begin with an uppercase F and then the other an uppercase L. And I personally don't like that. I like camel casing for my XML element names and attribute names. So we're going to use the XML attributes constructor, but we're going to use named parameters. The name that we want to use in this case is called attribute name, and we set that to whatever value that we want. So this is going to be first name in camel case, and we will just copy that and paste it for the last name. Of course, we will just need to change it to last name. So some attributes have positional parameters, others have named parameters, and then there's even other attributes that have both positional and named parameters. And of course, it all depends upon the attribute that you are using. The .NET Framework class library has a variety of built-in attribute classes. Some can help with serialization, others can help with validation, and of course, a wide variety of other attributes are used for different purposes. But a lot of times you want to write your own custom attribute, and doing so is relatively straightforward because all an attribute is a class. And a lot of the attributes that we write are simply there for informational purposes. So in this video, we're going to create an attribute that we can use to define the order of the properties of a class. Like if we wanted to serialize a person object and we wanted to dictate the order in which those properties appear in the output, then we could do that with an attribute. So let's first of all create two properties. We will have the first name, and then we will have the last name. And then we would decorate these properties with an attribute that would be called, let's go with display order. That's generic enough so that we could use it in a variety of different purposes. We could use it to output to CSV, or we could also use it to dictate the order in which these things would appear in a UI. Basically, anytime that we would want to dictate the order in which these would appear, this is what this display order attribute would be for. And then we could use a value for the sequence. So the first name is typically after the last name. So we could say that the first name is going to have a display order of 2, and then we could decorate the last name property with the display order with a value of 1. Well, now we need to create our display order attribute class, and we can do that manually, or we can let Visual Studio do it for us. If you move your cursor to somewhere inside of the display order identifier, press Ctrl Dot, and we have some options. Now we're going to take the first one. It's going to create our display order attribute class inside of a new file. But notice that we get a little preview of what that's going to look like. So let's go ahead and press Enter, and it creates that file, and it's already open. So we can go and look at it immediately. Now notice that the class ends with attribute. This is by convention. This is not a rule, but it's a good idea to end all of your attribute classes with the term attribute. That way you can identify what classes are and what aren't an attribute. And whenever you use the attribute in your code, you don't have to specify attribute. Now you can if you want to, but the compiler is going to link display order as our attribute here to the display order attribute class. The other thing that you should notice is that this inherits from attributes. Every one of your attributes has to inherit from attribute. Whenever you create a custom attribute, you control how and where that attribute can be used. Now, by default, it can be used anywhere else a normal attribute can be used. So a class, a property, a method, a struct, enum, assembly, there's a variety of places that you can use an attribute. But if you want to limit where you want that attribute to be used, like for example, this display order attribute is probably only useful for properties. So we could specify that this display order attribute can only be used on properties with this attribute usage attribute. You apply this to the class, and then you tell it where you want to use it. So there's this attribute targets enum, and there are a variety of values, but the one that we are going to use is property. Now you can use a variety of these values all at the same time by separating them with the pipe character. So if you wanted to use this attribute with both properties and methods, then you could do this, where you have attribute targets.property, and then have the pipe, and then you would have attribute targets method. But in our case, that really doesn't make sense. It makes sense only for the properties. And there are some named values that we can use as well. There's one called allow multiple, which will allow us to use the same attribute multiple times on the same entity. In our case, the entity is a property. So if we set allow multiple to true, then we can go back to our person class, and we could use the display order attribute multiple times on either one of these properties. So if first name was display order 2 and 3, then that would be valid because we set that allow multiple option to true. However, in most cases, we will just use the default value, which is false, but that option is there in case if you ever need to use it. There's another option called inherited that defaults to true, and this determines if the attribute inside of our person class is inherited in any derived class of person. So if we create an employee class, then the display order attributes inside of person are also inherited inside of the employee class. So for first name and last name, they will still have a display order of 1 and 2. However, if we set that to false, then those attributes are not inherited. But once again, most of the time, we want to use the default value. So in the case of our display order attributes, we are only going to specify that the attributes can only be used on a property. The next thing we need is our constructor. Now, whenever we used the display order attribute inside of the person class, We passed an integer value as an argument to the constructor. So that is what we need. We need a constructor with a parameter. So display order attribute, and int, we'll just call this position. And we want to store this, of course, in a property, but we don't want this property to be changed from outside of the class. So we are going to create a property that is an int. We'll just call it position, and it will be publicly gettable, but we want to make it privately settable. And then inside of the constructor, we will set our position property equal to the position parameter. And if we go back to our person class, then we will see that, well, we are still getting an error. And it's because the constructor is inaccessible. So let's change this to a public class, and we will change the constructor to be public as well. And then that will make the errors go away inside of our person class. As far as named parameters are concerned, our display order attribute doesn't really need one. All we need is the position value. However, if you need one for your attribute class, all a named parameter is a property on the attribute class. It is publicly gettable and settable. So let's add a string property, and we'll just call it foo, because this isn't really anything that we need for our display order attribute. It is simply here for the sake of completeness. We want this to be gettable and settable, and we will go back to our person class, and now we can set that foo as a named parameter. So we set foo equals, and then whatever value that we want. So we could do hello world here. And of course, we could have as many named parameters as we need, basically because we could have as many properties as we need for our attribute class. So as you can see, writing a custom attribute is relatively simple. In most cases, there's not a lot of complexity to it. The magic of an attribute actually takes place outside of the attribute class. Instead, there is some code that's looking for a specific attribute, and when it finds it, it does whatever it is that it needs to do. So in this video, we are going to make the magic happen. We are going to use reflection to enumerate the properties of an object, and we are going to serialize that object into a CSV record based upon this display order attribute. We have a position value that determines the position of a property in the CSV output, and we are going to be serializing this person class, or at least a person object. And you can see that the display order attribute is decorating both the first name and last name properties. The last name has a position of 1, and then the first name has a position of 2. So let's start by creating a new class called CSVConvert. And this can be a static class because we don't need to create a CSVConvert object in order to serialize an object into CSV. Then we will have a public static string method. Let's call it toCSV. And we want to be able to serialize anything. So we will accept an object, and let's just call that obj. Now, the first rule of reflection is that you need to get the type of whatever object it is that you're working with. So let's create a variable called type, and we will use our object's getType method. That will give us the type of our object. The next thing that we need to do is get the properties of this type. Now, we need to do this for two reasons. The first is so that we can get the value of the property, because that is what we are going to be using in the CSV output. The second reason is so that we can get the attributes that decorate that property. That way we can get our display order attributes, and we can get its position value so that we know where to put the property's value in the output. So we are going to use our type, and this has a method called getProperties. And we can also take this another step, and we could filter the properties based upon their types. So we could say that we want only the properties that have our display order attribute. So we're going to use the where operator, and we want to use attribute is defined, and then we tell it what type of attribute that we want. The first thing that we pass is the property itself, but then we need the type of our attribute. Now we're going to need this attribute type in a couple of other places. So let's go ahead and create a variable. We'll call it attribute type. and we'll just use type of display order attribute. That will give us what we need so that we can pass this as the second argument to this isDefined method on the attribute class. So we are filtering our properties based upon the attributes assigned to those properties. Now let's just execute that query with the toArray method. So we have all of our properties. Now we just need to enumerate over those properties. So let's use a for each loop for each property. In properties, we want to retrieve all of the custom attributes. So let's do var attributes equals and a property. And a property info object has a method called getCustomAttributes. And there are two overloads. The first just accepts a Boolean value. And in this case, we want to pass true. This tells it to search the entire inheritance chain for that property. And that is what we want to do because this display order attribute is inheritable. We could come in here and we can say inherited is equal to false. And then we would want to set false over here for the getCustomAttributes. But we don't want that. We want this property to be inherited. So we will use true here. But we can also filter the custom attributes that we get from this method by telling it what attribute that we want. So the second overload, we pass in the attribute type. So we have that already. And then we will pass in true because we want to search the inheritance chain. Now this is going to give us a collection of just objects. We can go ahead and cast this as a collection of display order attributes. So let's use the cast method. We will cast it as display order attribute, and then we will go ahead and call toArray there. And now that we have our attributes, we need to enumerate over them. So another for each loop, our attribute in attributes. And this is where the magic is going to happen. We are going to get the value of the property. So we want to use our property info object. This has a method called getValue, and we need to pass in the instance that we want to get the value of for that property. So that is our obj. The next thing we want to get is the position from our attribute. So let's do var position, and we will use our attributes and position. Now we just need to build our CSV, and we can do that with an array. So I'm going to create an array called CSV. This is going to be a string array, and we want the amount of elements to be the same amount of properties that have our display order attribute. And we have that with our properties variable. So we're going to initialize this string array to have a length of our properties. And inside of this second for each loop, where we have retrieved the value and the position, this is where we are going to say CSV, and then we will use the position as the index, although we will need to do -1 here, because inside of the person class, the display order starts with 1. Although I guess we could change this so that it starts with 0, and then display order of 1 for the first name. That would simplify things, so let's just do it that way. We'll go back to our CSV convert, and let's get rid of that -1. So CSV at the index of position is going to be equal to our value. Now, value here is an object. This getValue method returns an object because it doesn't know what type it is. We need to call toString here. Now, it is possible that value is null, so we can use the null conditional operator, so that if value is null, it will just return null. But if it does have a value of some kind, then it will call the toString method. But if value is null, we still want something. We don't want just null. So an empty string would be useful there. So we will use the null coalescing operator to give us an empty string if value is null. Now all we need to do is actually build our string, and we can do that with string.join. So return string.join. Our separator is going to be a comma, and then we pass in CSV for our array. Well, let's test this. Let's go to the program class, and let's create a person object. So we will new up person. Let's set first name equal to John, and then the last name will be equal to Doe. And then we will want to serialize this. So let's create a variable called output. We will use our CSV convert class. We will call the toCSV method, and we will pass in our person object. And then we just need to display that in the console. So we will use the writeLine method, and let's go ahead and use the readKey method as well. Now, we don't have to do this if we were running it with Control F5, but I'm just going to press the Start button up there. And there we have the results. We have Doe, John, which is in the correct positions. Our serialization worked. So with reflection, we were able to inspect the properties of an object. We were able to retrieve the attributes for those properties and generate the appropriate output. In the .NET Framework class library, you will find a ton of data types, and a good portion of those types are interfaces. And as you start to look at more complex classes, you will find that they implement a variety of interfaces. And that is especially true with collections. You won't find a collection that implements any less than 3 interfaces. So the first 2 that we are going to look at are absolutely vital for collections. Without them, we would not have collections at all. The first is called IEnumerable, and this is aptly named. This basically says that any object or class that implements this IEnumerable interface can be enumerated. And if we look at the definition of this interface, we will see what exactly makes that possible. It has a method called getEnumerator, and this returns a type that implements the second most important interface. It's called IEnumerator. This is an object that will iterate over a collection. It contains the state of a collection's iteration. If we look at that definition, we see what makes that possible. So as you are iterating over a collection, you are essentially moving to each item within the collection. So that's what this moveNext method does. It moves to the first item in the collection, and then whenever you are ready to move to the second item, you call the moveNext method. It returns a Boolean value. So if it successfully goes to the next item in the collection, it returns true. If you reach the end of the collection, then it returns false. So you are moving to the next item in the collection, and when you do so, you access that item with this current property. And then whenever you need to reset the enumerator, you call the reset method. Now that's very important because this enumerator contains the state of a collection's iteration. So if you reuse the same enumerator, you have to reset that enumerator in order to start at the beginning of the collection. Now, if you'll notice, these 2 interfaces are not generic, and typically all of the collections that we use today are generic. So that means that there are generic versions of these interfaces as well. And they have the same name, except that they reside within System Collections Generic. And of course, they are generic, so we end up having an IEnumerable of T and an IEnumerator of T. So if we look at IEnumerable of T, we're going to see something very similar to just the plain IEnumerable interface. We will have the same method for getEnumerator, except that this time it returns an IEnumerator of T. And if we look at that definition, we see something that's similar, except that it only has the current property. Now notice here that it implements the IEnumerator interface, so it still has those other members. So anything that implements IEnumerator of T has to implement this current property. It also has to implement the moveNext and the reset. But notice that this also implements iDisposable. So any IEnumerator of T has to be disposed of. Now from here, we need to go to an interface called iCollection of T. This is an interface that defines all of the methods for manipulating a collection. So whenever you need to add or remove or clear a collection, this is the interface that defines those methods. So here we have the add method, the clear method, and the remove method. These are for adding, removing, and clearing. But notice that there's also a method called contains. This will tell you if a collection contains whatever object or value that you are checking for. It also defines the count property. So if you need to get the amount of items within a collection, this count property will give that to you. If a collection is read-only, you can get that value with the isReadOnly property. And if you need to copy a collection to an array, then there's the copy to method. And just about every collection in the .NET framework implements this iCollection of T, and you can see that it implements IEnumerable of T and IEnumerable. Now from here is where we start to branch off into different types of collections, and we essentially have two. We have a list, and then we have a dictionary. We will start with the iList interface, because when it comes to collections, the list is the most common. Now, a list is a collection that can be individually accessed by index. So it's a lot like an array in that sense, but it's much more powerful. And we can see that the iList of T interface implements iCollection of T, IEnumerable of T, and IEnumerable. It defines three methods: index of, so that you can get the index of an item within the list. There is a method called insert, so that you can insert an item at a given index, and then you can remove an item by index. But then there's also the indexer, so that you can randomly access items within the collection by specifying the index. So the list gives you this functionality as well as all of the functionality of a collection. The dictionary is not index-based. It is a key value pair collection. So whenever you add an item to a dictionary, you do so by key. You specify the key and the value for that key. The interface is simply iDictionary of T-key and T-value. So if we look at that definition, we see that it implements iCollection of key value pair. Now, this is a data type in the system collections generic namespace. And if we go to the definition, we see what this is. We have a key and then we have a value. And the dictionary is just a collection of these key value pairs. So whenever we look at the dictionary, we have the indexer, but we don't specify it by index. We specify it by key. It has a collection of all of the keys. It also has a collection of all of the values. And then it has the methods similar to the iCollection interface for adding, removing, and checking to see if the collection contains the key. And then there's also another method called try_get_value, so that you can try to get the value of a given key. It returns a Boolean value. So if that key does exist within the collection, then that will return true, and it will also give you the value of that key with this out parameter. Otherwise, if the key doesn't exist, the return value is false. And finally, we have three other interfaces for read-only collections. The first is IReadOnlyCollection, and this only defines a single property called count to get the amount of items within the collection. So there aren't any methods for adding, removing, clearing, or anything like that because, well, it's a read-only collection. You shouldn't be able to add, remove, or clear a read-only collection. So notice that it only implements IEnumerable of T and IEnumerable. It does not implement the iCollection of T. Now, this is the base interface for the other two interfaces. The next one is IReadOnlyList of T. And this defines just the indexer so that you can access each element in the collection by its index. And then if we go back and look at the iDictionary, we will see something similar to the dictionary interface, except that it doesn't have the methods for manipulating that dictionary. So there is the indexer for accessing the items by key, and then there are the keys and the value collections. But notice that these are just IEnumerable. They are not implementing the iCollection because the iCollection has those methods for manipulating those individual collections. So with IEnumerable, there is no manipulation. It is simply giving you the keys and the values. And then there is the contains key method and the try_get_value method. So those are the interfaces that just about every collection in the .NET framework is built upon. Knowing what they are and what they do will help you use the correct collection in your code. An array is the most simple type of collection in the .NET framework, but that simplicity comes at a very high cost, because an array is also the most limited type of collection. Whenever you define an array, you have to define its size, or the amount of values or objects that it will contain. and you cannot increase the size of an array or you cannot decrease it. It is a fixed size. So whenever you want to create an array, you start with whatever data type that you want that array to contain. So if we wanted to create a character array, we would start with char, and then we would follow that with a pair of square brackets. And this is going to be a character array that contains the characters H, E, L, L, and O. So I'm going to call this variable hello. Now we have just declared a character array. We haven't defined it yet. So there is a very big difference between declaring and defining. Here we have just declared a variable called hello, and it is a character array. So at this point, we haven't defined its size. Now notice we have the same type of syntax for the main method's parameter. This is accepting a string array called args. So we can pass as big of a string array to the main method that we want to in this case. The same goes for the hello variable. We can assign as large of an array as we want to. But in this case, we just want to define an array that has HELLO for the individual characters. So whenever you define an array, you can do so using the new operator, followed by the data type, and then a pair of square brackets. And then inside of the square brackets, you define the size. So hello is a string with 5 characters. So we have just defined a character array with a size of 5. And then we could populate that array. We could use indexing syntax, which is the name of our array followed by a pair of square brackets. And then whatever index, we start at 0, and then we could set this to be H. And then hello at index of 1 would be equal to E, and then the next one would be L, and so on and so forth, all the way to hello at index of 4. And there are some times when this particular type of syntax is useful, but a lot of the times we already know the values that we want to populate our array with. So in that case, we can use array initialization syntax, where we have our variable name, and let's just go ahead and change this to var, because the compiler is going to automatically infer the data type based upon the value or the object that we assign to it. The initialization syntax looks like this. We have new followed by our square brackets, and then we have a pair of curly braces. And inside of the curly braces, we have the values that we want this array to contain. So we can go ahead and set those values. We separate each value with a comma. So H is going to be at index of 0, E is going to be at index of 1, L is index 2, the second L is index 3, and then finally O is index 4. The fixed size of an array is not the only limitation. It also has a very limited API. Let's comment out the link namespace so that we can see just the properties and methods given to us for array objects. So there's quite a few methods. Some of them are clone, copy2, getEnumerator, but the property that we use more often than anything else is the length property. This will give us the amount of elements within the array. So right now, our hello array has a length of 5 because there are 5 elements. But if we get rid of any one of these elements, then the length is going to be 4. So the length is not representative of the size of the array. It's representative to how many elements are in the array. If we look back at IntelliSense, we're not going to find a lot of useful methods. For example, if we wanted to search our hello array for the value of E, there's not a method that we can use on this array object. Instead, the .NET Framework has a class called Array, and it has a variety of static methods that we can use to search the array, to sort it, to reverse it, and a lot of other useful things. So if we wanted to search our hello array for the value of E, we would use array.indexOf, we would pass in the array, hello in this case, and then the value that we wanted to search for, E. This of course returns an integer value which contains the index of where E is found. So it would find E at the index of 1 and assign that, of course, to index. Now, this index of will search from the left to the right, and it will return the first index where it finds a match. So in this case, it's going to find L at the index of 2, and it will always return 2, because the L at index 2 is the first L in the array. But if you wanted to search from the end of the array, there's a method called lastIndexOf, which you could use. And if we look at IntelliSense, you will find all of the methods that we would normally expect on the array object itself, but they are here on this array class. So it's not as convenient as you might find in other types of collections. Now, the last thing that you should be aware of is that arrays are objects. They are stored on the managed heap, even arrays of value types. However, they are passed by value. They are not passed by reference, and we can prove that by looking at one of the methods on the array class. It's called resize. Now, I have said that arrays are fixed size. You cannot change the size of an array, and that is true because the resize method creates a new array with the new desired size. It copies the elements from the old array to the new array. Then it replaces the reference of the old array with the new array. So it creates a new array and destroys the old array. But whenever you call the resize method, you have to pass the array by reference. So you have to use the ref keyword followed by the array that you want to resize, and then the new size of that array. This does not return a new array. It simply replaces the reference of our existing array with a new array. As far as collections go, you can't get any simpler than an array. They have certainly served a purpose in the past, but their limitations make them less than ideal in just about every case of where you want to use one. Instead, we use a list, which is much more flexible. The list is the most commonly used collection. It is a generic collection, and thus it is 100% type safe. You can think of a list as a super array. It has the simplicity of an array, but it also doesn't have any of the limitations of an array. So there's no fixed size, and there's actually a nice API that goes along with the list class. So whenever you want to create a list of anything, it can be a value type, a reference type, delegates, it doesn't matter. You can create a list of it. You simply new up the list of t constructor, and you of course pass in the data type as the type parameter. So here I have just created a new list of string. Now you can pre-populate a list by passing an existing collection to the constructor. And it can be any type of collection, as long as it is an IEnumerable of string. In this case, we can pass that to the constructor, and that will pre-populate our list with that collection. So let's create an array called names, and we will use the initialization syntax. So we will have new, and then square brackets, and then curly braces, and inside of here, we will just have a couple of names. Let's have John, and let's also do Jane. So if we wanted to take this array of names and pre-populate our list, all we have to do is pass in that array to the constructor. But we can also use the initialization syntax to pre-populate a list. So let's change the name of these two. So list 1 is going to contain the names that are inside of our names array. We can essentially do the same thing by using a pair of curly braces, and inside of the curly braces, we would have our elements for this list. We would have John, and then we would have Jane. Now, you don't have to pre-populate a list if you don't want to. In fact, in most cases, you probably won't. You will just new up the list constructor, and then you will add items to the collection whenever you need to do so. You do that with a method called add. This will add an item to the end of the collection. So because we have an empty list, the end of that collection is at the index of 0. And of course, each time you add an element to the collection, it's going to add to the size of that collection. You can determine a list size by using the count property. This tells you the amount of items within the collection. So right now, the count is 1. Now, you can add multiple items at the same time if they are in a collection. So for example, let's change this. Instead of adding John, we're going to add Tim. And we are going to add John and Jane by using a method called addRange. You simply pass in another collection. In this case, it's just an IEnumerable of string. and that will add those items within that collection to this list 3 collection. So now we have a count of 3. We have Tim, John, and Jane. And we can access these values using index notation. So we can say list 3, and then we can have the index of 0. That will give us the name of Tim. Index 1 would give us the name of John. Index 2 would give us the name of Jane. Now, however, if you try to set a value with an index that does not currently have a value, you're going to run into an argument out of range exception. If we try to set the index of 3 equal to, let's say, Sam, this will give us an exception because our list only has a size of 3. So you can use index notation to set the value for a specific position within the collection. That position already has to have something there. And of course, by setting a new value at an existing position, like at index of 2, we have now replaced Jane with Sam. So anytime that you want to add a new item to a list, you need to use the add method. Now, you can insert a new item at a given position with the insert method. The first argument is the index of where you want to insert that item, and then the second is the item that you want to insert. However, you run into the same limitation as you did with index notation. That position has to have a value already there. So if we attempt to run this, we would see an argument out of range exception. However, if we change this to 2, then it is going to insert Sam into the index of 2, but it's not going to replace what we had there. It's just going to shift Jane into a position of 3. So at this time, our list looks like this. We have Tim, we have John, we have Sam, and then we have Jane. Now, it's important to note that a list is not a list of unique values. So if we wanted to add another John to this list, we could do that, and we would have 2 Johns inside of this list. So the shape of this collection would look like this. We would have Tim, John, Sam, Jane, and then John. And if we wanted to remove one of these Johns from the collection, we could use the remove method. Now, by using just remove, you have to pass in the item that you want to remove. And this is going to start at the beginning of the collection, and it's going to find the first match, and it will remove that item. So in this case, it's going to remove the first John. After we call remove here, we have Tim, Sam, Jane, and John. But if you wanted to remove all of the Johns from the collection, you could use the remove all method. But in this case, you can't just pass in an item that you want to remove. You have to provide a delegate, which would then determine what items to remove. So we can use a lambda expression, and we can say where S is equal to John. And in that case, all of the John items within this collection would be gone. So we would end up with Tim, Sam, and Jane. There's also a remove at method, which lets you remove an item at a given index. If we remove at the index of 1, that removes Sam from our collection, and we just have Tim and Jane. And lastly, there are the methods that search the collection. Now, there's one called contains that will tell you if provided value or object is contained within the list. So if we say contains Tim, then this is going to return true because our list does have an item with Tim. There are also the index of methods. Index of and last index of. These allow you to find the index of a given item. And then there are the methods that let you find items based upon certain criteria. The find method returns the first item in the collection that matches a condition. That condition is determined by a delegate, which we're going to use another lambda expression, and we're going to find an item in this collection that begins with an uppercase T. So if we use the starts with method and pass uppercase T, then we would get the value of Tim as the result of calling the find method. Now, if we had another item that began with an uppercase T in this collection, we would still get Tim, because that is the first item that is found inside of our collection that matches our criteria. However, if we wanted to retrieve all of the names with an uppercase T, then we would use the findAll method. This basically does the same thing, except it returns all items in the collection that match the condition. As you've seen, the list of T class gives us everything that an array does, and then some. This is why the list is the most commonly used collection. We don't use arrays anymore. We simply use lists. Despite its name, the LinkedList Collection is very different from a standard list. In fact, the only thing that they have in common is that they are both lists of something. And in most cases, a linked list hinders performance, but it excels at inserting and removing items from the collection. So whenever you want to create a linked list, you just simply new up the linked list constructor. You specify the data type that you want to contain within that collection, and there you go. So I have created a linked list of string and assigned that to the fruits variable. Now, adding items to a linked list is different from a standard list. There is not just an add method. Instead, we have 4 add methods. There is an add after, add before, add first, and add last. We'll start with add last and add first because they are the most simple methods. They are self-explanatory. Add last adds whatever item you pass to the end of the collection. Add first to the beginning. If we say add last and then orange, then that is going to add orange to the end of the collection. However, right now we have an empty collection, so orange is actually the first and last. But if we call fruits and then add first, let's pass in apple. That is going to insert the apple value at the first of the collection. So at this point, our collection is apple and orange. Now we will get to the other add methods here in a moment, but let's first talk about finding an item within the collection. Let's say that we want to find orange within our list of fruits. So we would use fruits and then the find method, and then we would pass in orange. But this doesn't give us a string. Instead, this gives us an object called LinkedList node of string. So a linked list, while it is a list of something, a string in this case, each item within the collection is actually a node, and these nodes are linked to one another. Each node has a link to the node in front of it and to the node behind it. That's why it's called a linked list. So we have our orange node here. If we look at its properties, there is a list property which gives us the list that this orange node is in. There is the next property which gives us the next node. Now, since orange is the last node within our collection, next is null. But there is a previous node which gives us the node prior to this node. So this is going to be a reference to our apple node. And then finally, there's a property called value, which gives us the value of this node, which is orange. So whenever you want to add an item before or after an existing item within the collection, you first of all have to specify the node that you want to insert before or after. So let's say that we want to add peach before orange. So we would use the add before method. We would pass in our orange node, and then we pass the value that we want to add. So in that case, that is peach. So now we have a collection that is apple, peach, and orange. Well, let's add another apple to our list. Let's do add before, and we'll just add this before orange. So that our resulting collection is going to be apple, peach, apple, and orange. And then let's do a find for apple. So we'll say fruits and then find and apple. So whenever you call the find method, it's going to start at the beginning of the collection and it's going to search until it finds a match. So because we have an apple at the very beginning of our collection, then the find method is going to exit and return that node. So our apple node here is the first. And if we wanted to find the second one, then we would use the find last method. So let's call this last apple, and we will call fruits.find last. We will pass an apple, and that will search from the end of the collection and go forward until it finds a match. And if you had an apple somewhere between the first and the last one, Well, then you would have to implement your own logic, because there's really nothing as far as the linked list class is concerned that will help you there, except for the fact that there are two properties that give you the first and the last items in the collection. So you could start from the first, and then you could iterate for as long as first.next is not null, or you could start at the end of the collection and go forward. So as long as the previous is not null, then you could walk the chain forward until you found another apple in the collection. Now, the linked list does implement IEnumerable. However, if you use the for each loop, then you are going to get a string value as opposed to the node object. So if we do var fruit in fruits, and we console write line, and we write each value, then we would see just the string value itself. We would not see anything in relation to the node. So if we inspect fruit here, we see that that is a string. And you could perform a search that way, but it is inefficient. But then again, most everything about a linked list is inefficient. The only thing that it is efficient at is inserting and removing items from the collection. As far as removing items is concerned, there is the remove first, and the remove last. So if you want to remove an item from the collection, you call remove, you pass in the value that you want to remove, or you can also pass in the linked list node if you have that, and that will remove that node from the collection. And then the remove first and remove last methods are rather self-explanatory. You don't pass anything to those methods. They will simply remove the first item from the collection or remove the last item in the collection. And so there you have the linked list collection. In most cases, you won't use this in your applications. But if you need to guarantee fast insertion and removal, then this might be the collection you want. In many of our applications, we need some way to map a key with a value. Now, that concept is typically referred to as a hash table, but in the .NET framework, we call it a dictionary. But it's the same thing. It's a collection of key value pairs, and it's very fast because it is built for the explicit purpose of looking up a value based upon a key. And the wonderful thing about a dictionary is that it is generic. So you can have a key and value of any data type. It can be a value type or a reference type. The only thing that you have to be careful of, if you use a reference type as the key, the hash of that object cannot change. Otherwise, you lose the mapping between that key and its value. I'm going to create a dictionary called types, and I'm going to make this a dictionary of string and string. The first type parameter is for the key. The second type parameter is for the value. Now, whenever you create a dictionary, you can just new up the constructor and you will have an empty dictionary. However, if you want to pre-populate it with a set of key value pairs, you can use one of two syntaxes. The older syntax uses curly braces to contain the key value pairs. So inside of these curly braces, we would have our key, which we're going to do txt, and then the value separated with a comma. And in this case, that's going to be the name of the program that will execute for that extension. And then for any other key value pairs, we just separate those by commas. The newer syntax uses more of what we would expect to with a key value pair. We would use the index notation, but in this case, the index is a string. So we would have txt equals, and then our value, notepad. And then each of these pairs would be separated with a comma. And of course, you can also add key value pairs to a dictionary. You can do so using the index notation. So let's do PDF equals, and that would be acrobat.exe. Or there is an add method. So we could do types and then add, and then the first argument is the key. Let's do docx. And then the second argument would be the value, which in this case would be oneword.exe. So there are two ways to initialize a dictionary, and there are two ways to add key value pairs to the collection. Now, due to the nature of a dictionary, your keys have to be unique. And if you try to add a new key value pair with an existing key, then you are going to run into an exception. So if we call the add method, and if we try to add another entry for PDF, then this would throw an exception because the key of PDF is already in use. However, if we use the index notation, then that is going to set a new value for that key. So if we rearrange this so that we add docx and then we add PDF, we can come back using index notation and set a new value for the PDF key. However, if we come in and change this to have a capital P, then this is going to set a new key value pair, because in C# and the .NET framework, strings are case sensitive. However, we can change that by passing in a comparer whenever we create our dictionary. So if we wanted our dictionary to be case insensitive for our string key, we could use string comparer dot ordinal ignore case, and this will give us a case insensitive dictionary. So once again, whenever we add PDF with the something value, we reset that value whenever we assign Acrobat to the key PDF, because now the keys are case insensitive. Now, when it comes to getting a value, we can do so in one of two ways. The easiest thing to do is to use index notation. So let's say var value, and we want to get the value for the PDF key. So we just use types and then the key PDF, and that will give us the value of acrobat.exe. However, the safer thing to do is to check to see if a key exists, because if a key doesn't exist, then we get an exception. So instead, we can use a method called try_get_value. Now, there are two arguments. The first is the key that we want to try to get a value for. The second is an out parameter. So if that key does exist, then the method will set the value for our out parameter. And this also returns a Boolean value. So not only can we try to get the value, but it will tell us if it successfully retrieved the value for that key. So let's create a variable that we are going to use for our out parameter. Let's just call this program, and let's initialize that as an empty string. And then normally we would use this with an if statement. We would say types try_get_value. We want the key for docx, and then we will pass in our out parameter, which is program. And if this is true, which of course it is right now because we have a key of docx, then we can do something with program. Or if we wanted to do the reverse, we could check to see if that didn't succeed. And if so, then we can set types with the key of docx equals to winword.exe. However, if we are going to do something like this, then we also need to set program equal to our new value. So we could do types and then docx. So let's leave the code like this, and let's get rid of where we add docx and winwords to our collection. Now, a dictionary also has two inner collections that we could use for enumerating the keys or enumerating the values. They are keys and values. And there's also methods that will let us check to see if we have a key or a value within the collection. Those methods are called contains_key and contains_value. And those, of course, return true or false based upon if we have the given key or the given value. Now, you can also enumerate directly over the collection, and this is a collection of key value pairs. So we can say for each var kvp in types, and in this case, our kvp is an object that has a key property and a value property. So if we wanted, we could say console.writeLine, and we could output the key, so kvp.key equals to kvp.value. And whenever we run this, we are going to see two items in the console, one for PDF, the other for docx. So let's go ahead and start without debugging. Although we do have txt, I forgot that we initialized our collection with that key value pair. And that's it for the dictionary collection. It's a very straightforward collection. It makes it very easy to map a key and a value together, and it gives us the tools necessary for using such a collection. The SortedList collection is more like a dictionary than a list, because it is a collection of key-value pairs, and as such, the API is very similar to a dictionary. So if you wanted to create a sorted list, you just new up the constructor and specify the types for the key and value. So let's create one called extensions, and the key will be a file type extension, and then the value would be the program that would run for that extension. So we will new up sorted list, and this is going to be of string and string. And we could use the initialization syntax to pre-populate our collection with a set of key value pairs, or we can use the add method to add keys and values later on. So let's add a key of txt, and the program would be notepad.exe. We can also use indexing notation. So we can say extensions and then PDF is equal to acrobat.exe. But we also run into the same issues that we have with the dictionary. If we try to retrieve the value of a key that doesn't exist, then we would get an exception. So in those cases, it's safer to use the try_get_value method. So let's create a variable called docx, and we will set that to an empty string. And then we would use extensions.try_get_value. We would pass in the key, so we want to get the value for docx, which of course doesn't exist in this case, and we specify our out parameter. And this is not going to succeed, so if not extensions.getTryValue, then we will add that key value to the collection. So we can say extensions and docx equals to winword.exe. And then, of course, we need to set the value for our docx variable. So we could just set that equal to either winwords.exe, but it would be better to just retrieve that value from our collection. That's what we will do here. And so the API between the sorted list and the dictionary classes are very similar. However, internally, they are different. A dictionary uses a hash in order to find the value for a key. The sorted list uses a binary search, and we will talk about that in a few moments because that does impact performance. However, there are two methods that I want to point out. These are methods that the sorted list class has that a dictionary does not. The first lets you get the index of a key. So let's just call this index. We want to use the index of key method, and then we pass in the key that we want to retrieve the index for. So if we pass PDF, then that will give us the value of 1, because the key value pair of PDF and acrobat.exe is the second item in the collection, thus the index is 1. The other method is retrieving the index of a value. So let's do extensions and then index of value, and we pass in the value that we want to get the index of. So if we say winword.exe, this is going to give us an index of 2. Now, I mentioned these two methods for two reasons. First, they're different than what you find in the dictionary class. The second is because this index of key method is used every time you try to get the value of a key. So every time you use indexing notation or you use the try_get_value method, it's going to call this index of key method to get the index of that key, and then it uses the values collection to return the value. It would look something like this. We have the index, then it would use values, and then use the index to retrieve that value. It's this index of key method where the binary search takes place. It searches the list of keys using a binary search, it finds the index, and then that index is used to get the value. So that's the main difference between a sorted list and a dictionary. The dictionary uses a hash algorithm, the sorted list uses a binary algorithm. And as I mentioned earlier, this impacts performance, because a binary search is typically slower than a hash search. However, a sorted list uses less memory than a dictionary. So there's a little trade-off there. And really, in small collections, the performance hit is negligible. So for smaller collections, a sorted list is actually the class that you want to use. It will perform well and use less memory at the same time. However, if you have a larger collection, then you will need to decide what's more important, performance or memory. These days, memory is cheap, so more often than not, you would want to use a dictionary. The HashSet collection is rather specialized. It's not one that we use on a regular basis. However, it provides a lot of useful functionality when you need to work with multiple collections and you need to identify duplicate values. It's also useful when you need to remove all duplicate values from a collection or multiple collections. Now, to create a hash set, you just simply new up the constructor. So hash set, this is a generic collection, so you specify the data type that you are working with. There you go. This creates an empty hash set. But most of the time, if we are going to create a hash set, we already have some collections that we are working with. So let's create a couple of arrays. I'm going to call the first one just R1, and let's have 4 elements in this. Let's have A, and then B, C, and then let's have a duplicate of one of these. Let's just pick A. So that is our first array. Let's paste that for our second array. It will be called array2, and let's have B, D, E, and F. So our first array has duplicate A values, and then between array1 and array2, there is a duplicate B value. So whenever you create a hash set, more often than not, you're going to pass it a collection. Let's pass our first array. Now, the constructor is going to take each element from this first array and add that to our set. And let's just change the name of this to set. And it's going to then remove the duplicates from the set. So what we have inside of our set at this point is A, B, and C. It's not going to change our existing array. That is still there with A, B, C, and A. But as far as the set is concerned, it is only A, B, and C. Now you can add items to a set with the add method, and you're not going to see an exception if you try to add a value that is already in the set. It's just not going to add it because that value is already there. So even after calling add at this point in time, we are still going to have a set with A, B, and C. The hash set is most useful when working with multiple collections, and one of its methods is to determine if there is an overlap between multiple collections. That means that it's going to check not only what is in the set, but in any other collection, and it's going to find if there are any items that are common between the two collections. That method is simply called overlaps. So let's do set and then overlaps. All we have to do is pass in the collection that we want to check with. So that would be our second array. And this would return true because there is one item within this second array that is in common with our set, and that is the value of B. However, if we create another array, let's just call this array 3, and we will have completely different values in this array. So let's have X, Y, and Z. And if we call the overlaps method and pass in this third array, then we are going to get the result of false, because there is no overlap between what is inside of our set and what is inside of the third array. A hash set also allows you to create a union between the set and another collection. So let's call the union with method, and let's pass in our second array. Now this is going to take the contents of our second array and add that to our set, but it's also going to remove all of the duplicates. Now there aren't any duplicate values inside of array 2, but there is a duplicate between array 1 and array 2. That is the value of B. So it's going to remove that second value of B, and now what we would have in our set is A, B, C, D, E, and F. We can also use a hash set to just give us the commonality between two collections. So we have our set, and we will call a method called intersect with. So set intersect with, and we will pass in, once again, our second array. Now, an intersection is finding what is common between the two collections and then modifying the set to contain only those values. So in this case, the only common value is b. So if we call intersect with on our set and we pass in the second array, then our set will be changed to just b. That is the intersection between our set and the second array. And we can do the opposite of an intersection, and that method is called symmetric except with. And like the other methods, we simply pass in the collection that we want the exception of, and this would change our set to contain A, C, D, E, and F. Now, it's important to remember that the union with, the intersect with, and the symmetric except with methods all modify the set that you are working with. They do not return a new set with the new values. So that is very important because some other collections behave differently. They return a new collection. The set's methods do not. Now, of course, they don't modify the underlying collections like the array1 and array2, but the set does change. Now, there are a few other methods that are common to other collections. Like, for example, there is a contains method, so that you can search the set for a value. This would, of course, be true because our set contains A. And then there's a remove method, where you supply the value that you want to remove, so this would remove A from the set. And then there's a remove where method that you can use to remove any items that meet a particular condition. It accepts a delegate, so let's write a lambda expression where our character is a D, or if it's an E. So this is going to remove those values from our set, and we would end up with A, C, and F. And that is the HashSet collection. And you only want to use it when you need the functionality of the HashSet. So if you need to determine if two collections overlap, or if you need the union, the intersection, or the exception of those collections. The SortedSet collection is a lot like the HashSet in that it is a set of unique values, and you can use it to find the overlap, the union, intersection, and exception between two collections. However, they are internally fundamentally different because a sorted set sorts the values. So anytime you add a value to a sorted set, it is sorted. So let's create a sorted set. We will new up the sorted set constructor, and we will specify characters as our data type. Now you can create an empty set, or you can pre-populate it with an existing collection. So I'm going to pass in the first array. Now notice the order in which the values are in this array, C, A, B, A. Those are definitely out of alphabetical order. Whenever we pass this array to the constructor, it's going to do two things. First, it's going to remove the duplicates, and then it's going to sort them. So we end up with a set that is A, B, and C. This sorted set class has an add method, and we can attempt to add another A value if we wanted to do that, but it's not going to work because A is already in the collection. It's not going to throw an exception, it's just not going to add that value. But let's do this. Let's add Z, and then let's add Y. Now, anytime that you add a value to the sorted set, it's going to sort those values. So we actually end up with a set that looks like this: A, B, C, Y, and Z, even though we added Y after we added Z. And you can use the sorted sets like the HashSet. So if you want to find the overlap or the union, so union with, you can also use the intersect with method, as well as the symmetric except with method. Now, the only difference here is that while yes, these are going to modify the set, it is also going to sort the set. So every union, intersection, and exception will give you a sorted set of values. Now, due to the nature of a sorted set, there are some properties and methods that are not found in the HashSet class. Like, for example, there are two properties that get the min and the max of a set. They are simply called min and max. And they get what is essentially the first and the last items from the collection. So min, in this case, would be A, and then max would be Z. So set.max is going to be Z. And then there's a method that we can use to get a view of a set. So let's just call this view, and the method is called getViewBetween. And we specify two values that we want to get the view of, and it's going to return a new set that has the lower value. Let's just pick A, and all of the values up until the upper values. If we pick A and Y for the lower and upper, we're going to get a new set assigned to the view variable that is A, B, C, and Y. And because getViewBetween returns a new set, this does not modify the set that we are calling it on. There's another method called reverse. Now, this doesn't return a set. Instead, it returns an IEnumerable of char in this case. And it simply takes the values of the set and reverses it. But it does not change the set at all. The set is still in alphabetical order in this case. But the collection returned by the reverse method is in reverse order. Now, like the HashSet, the SortedSet is a specialized collection. You don't want to use it for any purposes except for the functionality that it provides. It doesn't perform as well as other collections as far as lookups are concerned, but if you need a sorted set of unique values and you need to find the union, intersection, and exception between your set and another collection, then this is the class to use. There are many different types of collections in the .NET framework. You have the more common collections like list and dictionary, then there's the more specialized collections like hash and sorted sets, but then you have the really specialized collections like the queue, which serve a very specific purpose. Now, a queue is what we typically call a first in, first out collection. So we take things out of a queue in the order that we put them in. There's no random access. It is simply a queue. And you create a queue by simply newing up the queue constructor and of course specifying the data type that you're going to be working with. In this case, we're going to be working with strings. Now, if we had a collection of the values that we wanted to go ahead and populate this queue with, we could pass that collection to the constructor. But we are going to use an empty queue, and we are going to enqueue items whenever we need to. Now, other collections have methods like add or insert or things like that. The queue does not. The method to add an item to the queue is called enqueue, and you simply pass in the value that you want to add to the queue. So a queue is very useful in situations, well, where you need a queue, like for a help desk, for example. Let's say that we are working for a software company that writes enterprise-level software. They have a software package that's used across different departments, and there are different systems. So we can have an accounting system, and then we could have a legal system. Let's create a couple of variables to contain those names for those systems. Let's start with accounting, and that will simply be called accounting, and then legal, and we will simply set that to legal. Now, in a real application, of course, this would be designed completely differently, but for the sake of simplicity, this is going to work rather well. Inside of our queue, we have quite a few requests for accounting, so let's add a few accounting requests, but we also have some legal requests as well. And we happen to be on the team that's handling legal requests. And so we essentially want to filter out every request that is not a legal request. But we also need to handle these requests in the order that they were added to the queue. And the code could look something like this. Of course, it would be run inside of some cycle or loop. And the first thing that we would want to do is check to see if there are any items in the queue. Now we can do that with the count property. That will of course return the amount of items in the queue, and we can check to see if that's greater than 0. However, we could also just use links any extension method to get that same information. So the first thing is to check if we have any items. The next thing we need to do is see what the first item is in the queue. If it is a legal request, then we of course want to handle it. Now, one thing you have to be aware of is that whenever you remove an item from the queue, well, you've removed it. You can't put it back unless if you put it back to the end of the line. So what we do instead is we peek at the first item to see what it is. And that method is simply called peek. So we call peek, This will return the value without removing it from the queue, and we want to check to see if that is equal to legal. If it is, then we will handle the request, and then we want to remove it from the queue because we've already done our job. So we do that with a method called simply dqueue. So we have a method called enqueue to add items to the queue. Then we have a method called dqueue to remove items from the queue. And whenever you remove an item from the queue, then everything that is still in the queue gets shifted to the left. So for example, if we handle the request on line 21 for the legal system, then whenever we remove that from the queue, the next first item is what is on line 22 for the accounting system. And then whenever who handles that removes it from the queue, then the new first item is what we have on line 23 for the legal request. And whenever you dequeue an item, this returns the value that was removed from the queue. So if you needed that for some purpose, then you can retrieve that by simply assigning it to a value or passing it to a method or whatever it is that you need to do. Now, I can't stress this enough. A queue is a queue. You cannot randomly access the items within the queue. You cannot reverse the queue. It is simply the queue. You can, however, copy the queue to an array, and then you could do whatever it is that you need to do with that array. And you can do that with a method called copyTo. Now, you first of all need the array that you want to copy the queue to. So let's create an array. And we will create a new string array where the length is going to be whatever the count is of our queue. We will use queue.count, and then we will call the copyTo method. We will pass in our array, but then we can also specify the index at where we want to start copying. In most cases, that's going to be at the very beginning, but you can specify whatever index that you want. And then that will copy the contents of that queue to the array. Now the queue is still there, items are still there, nothing has changed as far as the queue is concerned. But you at least have an array which you can now randomly access, or you can reverse. And then if you wanted to, you could create a new queue and add in the reversed array to have your reverse queue. There's a better way to do that by using a stack, but we won't get to that in this video. Now there's another method that you can use to clear the queue. But whenever you clear the queue, there's no easy way to enqueue a bulk of values. The only way you can enqueue items is with the enqueue method. So if you had another collection of items that you wanted to add to the queue, you would have to enumerate over that collection and add in each item one by one. So when you need a collection with built-in, first out functionality, the queue is the collection that you want to use. It has a very simple API, and it's perhaps one of the most simple collections in the .NET framework. The Stack collection is another highly specialized collection. It's a lot like the queue, except that it is a last in, first out collection. So it's very much like a stack in real life. As you build a stack of stuff, you put them one on top of the other, and whenever you want to take something out of the stack, it's usually the one on top. The only difference within a stack collection is that it is forced upon you. Whatever you put in last is the first that you take out. There's no random access or anything like that. To create a stack, you simply new up the stack constructor, specify the data type that you're going to be working with, and then call that constructor. And then if you want to, you can manually add items with the push method. There isn't add, instead we have push. Now, this terminology comes from the idea of a pushed stack. You are pushing an item into the stack, thus pushing all of the existing items back as well. Now, we call a pushed stack simply a stack. There's no reason to call it a pushed stack. So we pass whatever value we want to add to our stack. Whenever we want to remove the last item, we call a method called pop. So we are essentially popping it off the top of the stack. And this removes that value. So it will remove it and then return it to whatever is calling it. Now, just like a queue, there is a method called peek, which allows you to peek at the value of the last item in the collection, and it will not remove that item. And then, of course, you can clear a stack by calling the clear method. Now, stacks are used all throughout computer science and computing systems. But one that comes to mind is the browser's history. As you navigate to different URLs, the ones that you have visited are pushed to the back history. And whenever you press on the back button, the last item in the stack is popped out of it. So let's write a very crude browser class. It, of course, isn't going to do any type of rendering or anything like that. We are simply going to use this as a concept. So let's have a private field that is going to be our back history. Let's make this read only, and this is going to be a stack of string. We could go the URI route, but strings are easier to work with, so we're going to go with strings. And let's just call this underscore back history, and we can go ahead and new up that constructor. Now we also need some way of tracking the current URL. So let's have another private field. This is not going to be read-only because we are going to change this value, and we will just call it current URL. And let's go ahead and initialize that as about blank. We could do that inside of a constructor, but there's really no need to because we can do that right here. Let's have a method that will allow people to navigate to any URL that's passed to it. So let's call it navigate to, and our parameter will be called URL. Now, whenever we go to a different URL, we want to take what is in our current URL and put that into the back history. So we will say back history.push. We will pass in our current URL, and then we will set current URL equal to what was passed to the navigate to method. And then we need the functionality for going back. So let's have just a method called back. We don't need to accept any parameters here. We are simply going to take what is in our current back history, pop the last item out of the stack, and set our current URL there. So really all we need to do is current URL equals back history.pop. Now there's a slight little flaw with this implementation. Whenever you click on the back button in a browser, the forward button is enabled so that you can go forward into your history. So really we need a forward history there, but that also can be implemented with a stack. So let's create another private read-only field that is a stack of string, and let's call this forward history. Let's go ahead and create that collection. And we will need to make some modifications to our existing code, as well as adding another method for going forward. Let's start with the back method. Now, we still want this code where we retrieve the item from our back history and set our current URL to that value. However, before we do that, we need to take our current URL and push that into our forward history. So here we will use forward history.push. We will pass in our current URL, and really that's all that we need to do there. And for our navigate to method, we need to clear our forward history. Because whenever we navigate to another URL, typing it into the address bar or clicking on the link, that essentially clears out the forward history. So after we push the current URL into the history, we will use our forward history's clear method to clear out that history. Then we will set the current URL to our URL value. And now let's implement a forward method. So let's have public void forward. And we for sure want to set current URL equal to forward history.pop. However, before we do that, we need to take our current URL and put it into our back history. And we have that code inside of the navigate to method. So let's just copy and paste. Now, the back and forward functionality should only be available if there is something to go back to and if there's something to go forward to. So we should add a check in both of these methods, first for the back method to check the back history. So if underscore back history, and we could use the any method, then we want to perform our back functionality. And we will do the same thing in the forward method, except that we will check the forward history instead of the back history. And if we wanted to make the back and forward history available, we could add two properties that essentially get the back and forward history, but it would use the toArray method to return those values as an array. We don't really want to make our back and forward history stacks available outside of the class. So let's just do the back history. Let's do public. Let's make this return an IEnumerable of string, and let's simply call it back history. Now, whenever you return a collection, you might always want to return a generic IEnumerable of whatever it is that you're working with. The reason being because this is very flexible. This can be used for an array, a list, even a dictionary, or any other type of collection that implements IEnumerable of whatever data type that you're working with. That gives whatever is consuming your API the ability to use whatever type of collection that they need. Now, internally, I would return a list or something like that. But for a public property, I typically always go with IEnumerable of string. The same is true for methods. If I need to return a collection, I typically return an IEnumerable. So we're going to have a getter here, and we are simply going to return underscore back history, and we will call the toArray method. That will give whatever is using this browser class the ability to see what's in the back history without changing the back history. And so that is the stack class. It gives us the last in, first out functionality that is useful in a variety of circumstances. The classes in System Collections Generic are going to serve our purposes most of the time. However, there are going to be times when we need some slightly specialized functionality, and in those cases, we will typically need to write our own collection classes. Now, we can inherit from any of the classes inside of System Collections Generic, or at least we can inherit from most of them, because most of them are not sealed. But let's start by creating a class called IEnumerator. So this is going to be a collection that will contain only even numbers. And this would be somewhat similar to a list, except for it being only even numbers. So if we wanted to, we could inherit from list of int, and that would go a long way as far as giving us the functionality of a list. However, the list of T class doesn't give us anything that we can override, except for the normal 3 methods that every class has available: the equals, the getHashCode, and the toString. If we look at protected override, there's nothing there. Now, we can use the new operator to overwrite one of those methods, but that's not really what the list class is for. The list class is there to be a list. It's not there to be a base class. There is, however, a class called Collection of T. Now, this does not reside within System Collections Generic. Instead, it is in System Collections Object Model. The reason being because this Collection of T class is used as a base class. And this gives us 4 or 5 methods that we can override that are protected. Now, there aren't any public methods, like the add method. We can't override that. However, the add method calls a protected method in order to add the actual items to the collection. So let's do protected override. And the one that we are going to override first is this insert item. This is the method that is called by the add method. So if we come back to our program class, let's just do even numbers equals new even number collection. Whenever we call the add method, it's going to internally call that insert item method. So if we do even numbers dot add, and we'll just add in the number of 2. So we go back to our even number collection. This is the code that would execute. However, we want to only add those numbers that are even. So we can add a check here. If the item, and we could use the mod operator, is equal to 0, then we will add the item to the collection. Otherwise, we could throw an exception, but in this case, we're just not going to do anything. Well, let's go back to the program class, and let's add another even number. And it doesn't matter what it is, as long as it's even. Let's do the number 8. And then we will add yet another value, except this one is not going to be even. Let's make this 5. And then we are going to display the count of our even numbers in the console. So let's do console and then right line. We will do even numbers and then count. And then we will also add a call to read key so that whenever we run this with F5, the console window will stay open. So we see the value of 2 in the console. That's exactly what we expected because we are filtering out the odd values. However, let's do this. Let's say even numbers at index of 1 is going to be equal to 7. And then let's display this value in the console. Now we are going to see the value of 7 in the console because we did not override the method that's used for setting a value using index notation. So whenever we run this, we will see 7 in the console, and there we go. So we need to go back to our even number collection. And the method that we want to override is protected, but this one is going to be called setItem. This is used whenever you set an item in the collection using indexing notation. And we basically just want to do the same thing that we did inside of the insert item. We want to check if the item is an even number, and if so, we add it to the collection. Otherwise, it just gets filtered out. So if we run our application again, we see the value of 8, because now we are filtering out the odd values whenever we both set an item and whenever we insert or add the item. Now, there are other methods that we can override. If we look at IntelliSense, we can see what they are. We have clear items, so anytime that we call the clear method, then this protected clear items method will execute. And if we needed some special functionality there, we could do that. We can also override the remove item method. That's called whenever we remove an item from the collection. So we can hook into these methods and add our special functionality if we needed to. We're not going to, because this is really all that we need to do for this even number collection. Well, let's write another class, one that we could use to filter anything that we want. So let's call it FilteredCollection, and we'll make this public. Let's also make it generic so that we can use it with any type. And we want to inherit from collection of T. And we, of course, need a using statement for system collections object model. Now, our filter is going to be a func of T and bool. So it's going to accept an object or value of T and return a Boolean value. And we'll just call that underscore filter. And we will get that filter through the constructor. So our parameter will be a func of T and bool, and we will simply just call that filter. And then inside of the constructor, we will set our field equal to what was passed as the parameter. So then all we need to do is execute our filter inside of the set item and insert item methods. So let's just copy what we have from the even number collections. We'll paste that. We do need to change the data types for our items. These are going to be of type T. And of course, we want to use our filter in the if statements. So we will call our filter, we will pass in the item, and that will essentially give us our filtered collection. So if we wanted to now, we could change our even number collection to inherit from this filtered collection. And we could set our filter to essentially execute this code. That way we don't have to override these methods. So we can get rid of those. And instead of collection, we want to inherit from filtered collection. Now, we could make this generic if we wanted to, but we'll just leave this without any type parameters. Now, we do need our constructors, so public even number collection, but this is simply going to call the base constructor. And for our filter, we will accept an item, and we will use the mod operator and determine if it's even or odd. We'll leave the program class alone, and we will just run the application. We will see the same result as we did before. We have the value of 8. If you'll remember, we set that value, then we tried to override it with an odd value, but we saw that that didn't work. We have filtered out all of the odd values. And so whenever you need to write your own collection with your own special functionality, the collection of T class in System Collections object model is the collection that you want to inherit from. In the System Component Model namespace is a class called BindingList of T. Now this is a list, and it has all of the functionality of a list. However, it also has some very specialized functionality. It fires an event anytime that you add, remove, or reorder the items within the collection. Thus, it makes it very useful for binding data, thus the name BindingList. Now, we typically only use this collection for binding data in Windows Forms applications. It was added in .NET 2, and every control that supports data binding in Windows Forms really wants a binding list, or at least a collection that implements the IBindingList interface. So if we look at the definition of this class, we're going to see that it implements collection of T, and then it also implements a variety of other interfaces. But the one that we want to focus on is this IBindingList, because this is where the event is defined. It's called list changed. And whenever you set the data source for a Windows Forms component that supports data binding, it adds an event handler for this event. And so to demonstrate this, I've written a very simple Windows Forms application. It has a combo box that's going to display a list of names, and then there are two buttons, add and remove. Now, the add button is supposed to add names to the list, and the remove button is supposed to remove the selected name from the list. Now, notice that nothing is happening. We are clicking on add, but we don't see any new names added to the list. And whenever we select a name, let's select Tim Johnson, and if we click on remove, nothing happens. Now, there is code behind these buttons, and in fact, they are executing and they are doing what they are supposed to do. However, the combo box is not updating as the collection updates. The reason is because I've used just a simple list as the data source for the combo box. The combo box in this application is called a name combo box, and you can see that I set its data source equal to something called underscore people. And if we look at that, we see that that is simply a list of person. Now, this person class simply has a first name and a last name. And we can see that I populate this underscore people with a collection that results from calling dataSource.getPeople. So if we look at this method, we're going to see that I create a list of people, and I also initialize that list with several people, and then I return that list. But notice the return type. It is IEnumerable of person, which isn't that big of a deal for creating a list. But we're going to change this to a binding list of person, because then the combo box can automatically update itself as the binding list changes. And whenever we call the binding list constructor, you can see that we have an error. And the reason is because we can't pass just an IEnumerable to the binding list constructor. Now we can use the default constructor, but we want to pre-populate this with our existing people. So whenever you want to pass an existing collection to the binding list constructor, it has to implement the IList interface. So we can fix this by just calling the toList extension method, and then everything is going to work okay. So if we run this again, we can click on the add button, and then we can see that there were several names added. And then we can pick a name. Let's just do Jane Robertson. Let's remove that name, and we see that the list automatically updated. Now, if we look at the code for the add and remove buttons, we see that it is very simple. We are simply adding things to the collection, or we are removing things from the collection. We don't have any UI code as far as refreshing the combo box and adding and removing the items. All of that is handled by the combo box itself, because we bound our data using a binding list. Now, the binding list also allows us to factory create our objects. So instead of calling the add method and then passing in a new person object, we are going to use a method called add new. So let's do var person equals, we will use our collection and then call the add new method. Now, whenever you call the add new method, that's going to fire an event called adding new. So we need to listen for that event. So inside of the forms constructor, let's add an event handler for the adding new event. And then inside of this event handler, we are going to create our person object. Now, this adding new event args object that we get has a property called new object. And this new object is going to be returned by the add new method. So here we are going to create our person. Now, this helper method just creates a new person object that has a somewhat random number. That number is the result of getting the amount of items in the combo box. So sometimes we will have a unique count, other times we will not. It just depends upon how many names we remove and how many names we add. But in a real application, we would display a dialog box. We would have a text box for the first name, another for the last name, And we would get those values, create our person object, and then assign that person object to this new object. And so back inside of the add button click event handler, we have our person object, and let's add a stipulation. We only want persons that do not have the number 7 in their name. So if person.firstname contains, and we'll just check for the number 7, then we don't want that person in this list. So we can cancel the creation of a new item by using the cancel new, and then we have to pass in the index of that new person. So we can use the index of method and then pass in our new person object. That will give us the index, which we can then cancel the new creation of that person. So if we run this again, let's click on the add button first, and we have John Doe 5. We click on add again, we have John Doe 6. Now, whenever we click on add again, we should not see John Doe 7 because we canceled that person. However, we can't go past that because every other John Doe that we create is going to have the number 7. Because once again, the number that we have is based upon the amount of items within the collection. So the binding list is a very useful collection. Not only can we use it as a list, but it also has the extra functionality of keeping track of when things change within the collection itself, and it also gives us the ability to factory create new items. Now, with saying that, it is called binding list, and I'm a big believer that code and names have meaning. A binding list should be used when you are binding data to something. It doesn't have to be a Windows Forms application, it can be something else. But don't use it for any other purposes, because it was designed as a collection for binding data. In the System Collections Object Model namespace is a class called ObservableCollection of T. This was introduced in .NET 3, and it was provided as a means for binding data in WPF applications. However, you don't have to use this just for data binding purposes. This is a generalized collection, so you can use it any time that you want to be notified as to when the collection changes. So in that sense, it's a lot like the binding list, in that it fires an event whenever the collection changes. However, there's no extra functionality. There's no list type functionality. There's no factory creation functionality. It is simply a collection that fires an event when that collection changes. So let's create an observable collection of string, and I'm just going to call it stuff. And the first thing that we want to do is listen for the collection changed event. That is, after all, the whole reason why you would want to use this collection. And whenever a change occurs, you want to know what that change is, because that is going to determine what you do inside of the event handler. So for the event args, we have this notify collection changed event args. That's a mouthful to say, but it gives us a lot of information about the change that occurred in this collection. So let's say that we wanted to write something to the console whenever an item is added to the collection. So we can use this action property on our event args, and we can check to see if that action is add. That of course means that an item or items were added to the collection, and we have access to those new items. We have a property called new items, which is a collection of all of the new items that were added at the same time. So we can have a for each loop var item in e.newItems, and we want to write to the console saying that this value was added to the collection. Now, the items inside of this new items are simply objects. We need to cast them into whatever type that we need them to be. So let's just do that by casting each item to a string, and then we will write to the console the value, and then we'll say was added to the collection. But it helps if you have the syntax, right, for our formatted string. So if we add a few items to the console, then we are going to see those values, and then the phrase was added to the collection. So let's do stuff.add, let's say hello, and then let's also say world. So nothing too spectacular, but we will at least see the result of this. Now we also need a call to one of the read methods so that the console stays open. and we will press F5 to run the application, and we see that hello was added to the collection and world was added to the collection. Now, of course, adding items are just one type of change that can happen to this collection. So if we look at the notify collection changed action, we can see the other actions that we can listen for. If we move items, remove items, replace them, or reset the collection, then we can do whatever it is that we need to do in those circumstances. So if we wanted to do essentially the same thing for whenever we remove items, we could just copy that code. We can paste it in. We need to change our check here for the action. Now we want to check for the remove action. We'll change our string to was removed. But then we need to change what we are iterating over. We don't want the new items anymore. We want the old items. And so let's remove one of these items. Let's remove world. So we are going to add world, and then we are going to remove world. And whenever we run this again, we are going to see hello was added, world was added, and then world was removed. And we can also get the indexes of these items. So as we add, remove, or reorder the items, we can get their indexes with the new starting index or the old starting index. But most of the time, we want to deal with the items themselves. So new items and old items are going to give us what we need. Now, the observable collection of T implements two interfaces. Well, actually, it's more than two, but there are two that set this apart from other collections. So if we view the definition, we can see what those are. The first is IEnumerator changed. Now, this is the interface that brings in the collection changed event. So if there is anything that requires an IEnumerator changed object, then you can use an observable collection. The second interface is IEnotify changed, and this defines an event called property changed. Now, the property changed event is protected in the ObservableCollection class. So you only have access to it if you are inheriting from ObservableCollection. In fact, you can see it right here on line 60. So for the most part, the observable collection of T is straightforward. It's easy to use, and you can use it anytime that you need a collection that notifies you when it changes. The KeyedCollection class is rather unique for a variety of reasons. First, it is a hybrid between a list and a dictionary. You can access the items through the index, or you can access an item by its key. But here's the thing, the key is actually part of the value, and we have to write the code that extracts the key from the value. And then the second thing is that this is an abstract class, so we cannot create a keyed collection directly. We have to create our own collection and inherit from KeyedCollection. So let's do that. But let's first of all look at a class that I have already written called employee. It has two properties, ID and name. So as far as a key is concerned, you could say that the ID would be a key, but for a keyed collection, the key is part of the value. So in this case, the value is the employee object, and then the key is that employee's ID. So let's create a collection that is going to contain our employees, and let's just call it employee collection. And we want to inherit from the KeyedCollection class. So we need to add a using statement for system collections object model. And then we also need to specify the type parameters for the key and the value. In this case, the key is an int, the value is an employee. Now there's one abstract method that we have to implement within this class, and that is called getKeyForItem. This is the method that's used in order to extract the key from our employee. So inside of this method, we just simply want to return item.id, although this said employee collection and not just employee. So let's change that, and then we will return item.id. Now, there are a variety of other methods that we can override if we want to. If we look at protected and override, you will see that we have the clear items, the insert item, the remove item, and the set item methods. These are all methods of collection of T. And if we look at the definition of KeyedCollection, we can see that it inherits from collection of T. But notice that it doesn't implement the IDictionary interface. Instead, there is a property called dictionary. And whenever you add an item to a keyed collection, it's going to take the key and value and add that to the dictionary. So when you do a lookup by key, it is fast because it is using the dictionary for the key value lookup. Well, let's go back to the program class and let's create our employee collection. We'll just call that employees, and we will new up our employee collection constructor. And then we can start adding employees, but we do so by just passing in the employee object. We don't specify the key because whenever we add an item, the employee collection is going to extract that key by calling this get key for item. So the API is simplified. So let's call add, and we will new up our employee. We will set the ID to 1, and let's give our employee a name of John. So if we wanted to retrieve this employee from our collection, we would use employees, and we could use the index of 0, or we can use the key of 1. However, this might be a problem because our keys are ints, and that could interfere with the lookup. However, the key has precedence. Whenever you use indexing notation, if your keys are integers and if they have the same values as an index, the key is going to take precedence. And we can prove that by adding another employee. Let's change the name from John to Jane, and we will retrieve the employee with the key of 1, and we will write that name to the console. So let's do console.writeLine. We want the name of that employee. Then let's call one of the read methods so that the console window will stay open. And we have an issue that is inside of the employee collection because we didn't clear out that protected override there. So whenever we run this again, we see John in the console. So with integer keys, the key takes precedence over the index. And that is important to remember. Because if you were iterating over a collection with a for loop, then you would run into some very interesting results. Now, as far as methods are concerned, it's standard fare because this class inherits from collection of T. So really the only other notable method is the contains method. Now, there are 2 overloads. There's one that accepts the key, or you can pass in the employee object, which we don't have one, unless if we used the employee collection, and that of course would return true. So the keyed collection is rather simple and straightforward, and it's also a nice collection to use. You have the speed of a dictionary and the convenient API of a list. Sometimes you just want a collection that cannot be modified. And I know that that doesn't sound very useful, but it's actually something that you want to do very often. Let's look at an example. Let's create a new class, and I'm just going to call it My Company. And inside of this class is going to be a private list of all of our employees. So let's do private read-only list of string, and we will call it underscore employees. Let's go ahead and create that object as well. Now, of course, the read-only keyword is used for the field so that we cannot set underscore employees to anything else. And inside of this class, sometime we want to populate our employees. But we'll just assume that we have some information here. And we want to provide anybody using this class the ability to get our employees. But we want to do so in a way that doesn't harm our internal list. So let's start with public void, and we'll just call this get employees. And then we just need to decide how to go about making our employees accessible. Well, the most basic thing that we can do is return an IEnumerable of string. And then we can come in here and say return underscore employees. But that's not really good enough because anybody calling this method could then just take this IEnumerable of string and cast that as a list, and then they have complete and total access to our internal list, and we don't want that. So what we would typically do then is just return the array of this list. That's going to copy all of the items into an array and return that array. That protects our internal list, and it also gives anybody using this method the flexibility to do whatever it is that they need to do with our employees. So if they need a list, they could take this IEnumerable, and then they could pass that to the list constructor, and then they can do whatever it is that they need to do. But the key thing here is that we have protected our internal list of employees. But the IEnumerable is the most basic thing that we can do. The only functionality that it provides is simply enumerating over the collection. So instead, we could return a read-only collection. And this is a collection that resides within System Collections Object Model. And while this is read-only, it does give anybody consuming this method a little bit more functionality than just a normal IEnumerable. So in this case, we want to new up the ReadOnlyCollection constructor, and we of course need to specify the type parameter, and then we just pass in our list of employees. That's going to give whoever is consuming this method a read-only collection that they can then do some basic stuff with. So let's do var company equals new my company, and then we want to get our employees. And we would use our company object. We would call the getEmployees method, and then we can just look at IntelliSense and see what exactly we have. Although, let's get rid of the link namespace so that we can see just what the read-only collection gives us. So the first thing is this contains method. So we could search this collection for a given employee. And that, in and of itself, is probably worth it. Then there's also the count property. There's also the index of method. And really, that's it. Now, there's also a read-only dictionary, which is a lot like a read-only collection, except that it is a dictionary. So let's go back to our My Company class. And instead of a list of string for our employees, let's have a dictionary of int and string. The int would be the employee number. So let's change this to a dictionary of int and string. We will still call it underscore employees, but this is also going to force us to change our getEmployees method. However, it would be useful to still be able to get just the employee names if we wanted that. So let's copy this getEmployees method, and we will change the name to getEmployeeNames. We will still return a read-only collection, but we want only the names. So we will use the values property, but notice that Visual Studio is telling us that this is an error. The reason is because we have to pass an iList to the read-only collection constructor, so we can just convert that to a list with the toList extension method, and then that fixes that. Now for our getEmployees method, we no longer want a read-only collection, we want a read-only dictionary. And it is, of course, going to be of int and string. And we will simply pass in our underscore employees to the read-only dictionary constructor. And now we have our read-only dictionary. So we can come back to the program class. Let's do employees dot, and we can see what we have at our disposal. Now we have the contains key method to search for a given key. We also have the count property. We have the keys collection so that we could get all of the keys as well as all of the values. And we have the try_get_value method. So whenever you need to return a read-only collection or a read-only dictionary, consider using those classes. They're not as generic as returning an IEnumerable, but they also have slightly more functionality than IEnumerable. I have to admit that the first time I heard about the ReadOnlyObservableCollection, well, let's just say I had a difficult time thinking about how something like that could exist. I mean, because by its very nature, an observable collection is going to change. We are going to add, remove, and reorder the items within that collection. How can something like that be read-only? But then I came to the realization that it's just like any other type of read-only collection. It's there so that we can provide other people the ability to observe our collection without giving them the ability to add, remove, or reorder the items. So from that perspective, it makes perfect sense. However, it's not all kittens and fluffy bunnies, as you will soon see in a few moments. But let's first of all create an observable collection. I'm going to simply call it O, because that's a lot easier to type. And we will make this an observable collection of string. Then let's create a read-only observable collection. Now, whenever you call this constructor, you have to pass it an observable collection. There is no default constructor. There's no other overload. It accepts an observable collection. So you need to have that ready before you create your read-only observable collection. Now let's remove the link namespace from our using statements so that we can see what exactly the read-only observable collection gives us. That's it. There are no events that we can listen to. And if you're scratching your head thinking, why aren't there any events so that we can observe this collection? You are not alone. But for some reason, those events are protected. If we look at the definition, we can see that the read-only observable collection inherits from read-only collection, but it also implements the INotify collection changed and the INotify property changed interfaces. These are the same interfaces that are implemented in the observable collection. But then we see the collection changed and the property changed events are protected. So there are two ways around this. The first is to either cast our read-only observable collection as an INotify collection changed object, or we can just simply be explicit in our typing so that whenever we create that read-only collection, we can specify the interface as the type, and then that will give us access to the collection changed event. Now, the alternative is to create our own class and inherit from read-only observable collection. However, in doing so, we would have to deviate from the standard API. So anybody consuming our code would have to know that the event is not called collection changed. Instead, it's called something else. Or the alternative is to just overwrite the existing plumbing for the collection changed event. Either way doesn't sound good to me. So really the best choice is to just return a read-only observable collection and then let the consuming code either cast that as an INotify collection changed or use explicit typing like I did here. Because really, it's not up to you to set up this event. It's up to whoever is consuming your code. So if you return read-only observable collection, you've done your job. You've told them that this is a read-only observable collection, and it's up to them to actually observe it. So despite its name, it's actually a reasonably useful class, even with its little weird quirks. Starting in .NET 4, Microsoft began to emphasize parallel processing, and one of the things they added to the .NET framework was a new namespace called System Collections Concurrent. And the collections inside of this namespace are thread safe. That means that you can use them across multiple threads. What we are going to look at in this video is called a concurrent dictionary. So it is a thread safe dictionary. When you create one, you of course need to specify the data types for the key and the value. So this is going to be a concurrent dictionary of int and string. Let's just call it _dictionary, and we will go ahead and new up that constructor. Now, because this is thread safe, that means that we can add, remove, modify, do whatever we need to do to this dictionary across multiple threads. Other than that, the primary differences between the concurrent dictionary and a normal dictionary are the methods that we use for doing those things. Like, for example, if we want to add an item to our dictionary, we don't have an add method. Instead, we have a try add method. And you'll notice in IntelliSense there are multiple methods that begin with try. Try add, try get value, try remove, and try update. These methods return a Boolean value. They return true if they successfully do what they are supposed to do. They return false if they don't. Now, most of the time, if they return false, it's because they were supplied with an invalid key. Like, for example, if we try add a key of 1 with a value of hello, and let's just copy this code and paste it without making any modifications. Now, in a normal dictionary, this would throw an exception. But with a concurrent dictionary, there is no exception. The try add method will simply return false. And that's really what you want, because if you are trying to add a value with the same key across multiple threads at the same time, you don't want a ton of exceptions being thrown. So it makes sense for these methods to return a Boolean value and not throw an exception. But we are going to change this. Let's add a key of 2, and the value is going to be world. But also, this is for multiple threads. So right now we're doing everything in one thread. Let's add a method that will then be used in another thread. Let's just call it A. And inside of this method, we are going to add another item to our dictionary. So let's have the key of 3 and the value of foo. And then let's copy this and use it as the basis for the B method, which is going to do something else. Let's remove something. So removing an item, of course, removes it, but it also retrieves the value of that given key. So let's first of all create our value. Let's initialize it as an empty string, and we will use the try remove method. We will pass in, let's do the key of 1, and this is an out parameter, so we will say out value, and we can leave it at that. And let's have another method, one that would be used in another thread. So let's copy what we have for B. Let's call that C, and let's call the try update method. So we are going to try to update an existing key. Let's update the key of 2. Let's set its value to world2. And then there's a third parameter called comparison value. Now, this can be interesting. We can only update a key with a new value if whatever we supply as this comparison value is the actual value of that key. So if we pass in world here, then this update is going to take place. The try update method is going to return true, and we will now have a new value for the key of 2. However, if we set the comparison value as world3 with no space, then this try update is going to fail. It's not going to update the key, and the try update method is going to return false. Now, this is actually a very good feature because you only want to update a key if you know what that value is. If you don't know the value for that key, then if you update it, you might be really messing up your collection. So it's a failsafe. Yes, you can update a key, but only if you know what the existing value is. So this is going to fail. But let's also have an example of where it does pass. So the first one will fail, but the second one will succeed. Now, of course, we need different threads for these things. So let's create a thread. We'll just call it T1. We want to create a new thread, and we do need a using statement for system.threading. And we also need our thread start. So new thread start, and we will pass in the A method here. So A. And then we will do the same thing for our other methods. So let's copy and paste this line of code. We'll call the second T2, then we will have T3, and T2 will be a thread for the B method. T3 will be a thread for the C method. Then we want to start those threads, so we will call the start method on each of these, and we will also call the join method as well. So let's just copy these 3 lines, and we will bulk change this to call the join method. Now, if you don't know how to box select in Visual Studio, this is fairly new. I think it was a new feature in Visual Studio 2010. So you just hold down the Alt key, you select what you want to select, and then just start typing. Now, there are 2 other useful methods that you can use to manipulate the keys and values of the dictionary. The first is called add or update, and as its name implies, you are adding a key and value, or you are updating the value for a key. So the first thing you pass is the key that you want to add or update. The second is the value that you want to add for this key if it doesn't exist. So let's have the value of dog. And then the third is a function that takes an int and a string, and it returns a string. So let's have key and value, because that is essentially what we have here. And then we could do whatever we wanted. Now, if we wanted to completely change the value, then, we could specify a return value that's completely different. Or we can take the existing value and concatenate that with something else. So we can have the string value of the number 2. Now, this is going to give us the key of 7 and the value of dog, because we don't have the key of 7, and as such, we are adding that key with what was passed as the second parameter. However, let's copy and paste this. So we are calling essentially the same code. Now we do have a key of 7, so we are not assigning a new value here. Instead, we are updating it. So our function is going to execute, and so for the key of 7, we will have the value of dog 2. The second method gets or adds a key and value. So let's do dictionary and then get or add. Now this accepts 2 parameters. The first is the key that we want to get or add. So let's have the key of 8, and let's have the value as cat. So because we don't have the key of 8 in our collection, it's going to add the value of cat for the key of 8. And the get or add method is going to return our value. So here, our cat variable is going to contain the string cat. However, if we do the same thing, if we say cat equals underscore dictionary, get or add, and we have 8 for our key, and we try to set a different value, like fish, we are still going to get cat, because this method gets or it adds. If one already exists, then it's going to return that existing value. And so there you have the concurrent dictionary class. Now, you only want to use this class with multiple threads. If you are writing a single threaded application, use a normal dictionary, because the concurrent dictionary is considerably slower than a normal dictionary. But if you have a multi-threaded application, then the concurrent dictionary is what you want to use. There aren't many collections in the System Collections concurrent namespace. There are, however, concurrent versions of the queue and the stack. The queue is called ConcurrentQueue, so let's create a concurrent queue of string. And just like a normal queue, if you have an IEnumerable of values that you want to pre-populate that queue with, you can pass those to the constructor. The stack is also very similar. It's called ConcurrentStack, so let's create a concurrent stack of string. And once again, if we had items, we could pass those to the constructor. Now, there's another type of collection called a ConcurrentBag, which we will talk about in a few moments. It's a lot like a stack, but it's not guaranteed to be in order. And it's also not a collection of unique values. So it shares some similarities with a stack, but it's not a stack. So let's start with the queue. Now, the API is going to be very similar to a normal queue, except we are going to see some of the try methods that the concurrent dictionary has. We'll start by enqueuing a few items. So the enqueue method is the same. It is simply adding items to the collection. And so we will enqueue hello and world. But then things start to change when you want to peek or whenever you want to dequeue things. So instead of a peek method, we have a try peek method. This returns a Boolean value. If it was successful, then it returns true. Otherwise, it returns false. And we pass it an out parameter. That's how we get the value of the first item in the queue. So let's save our first equals, and we will initialize that as an empty string. Then we will pass out first to the method. So if we were going to use this in our code, it would look something like this. If queue try peek, and if this was successful, then we would do something with our first value. Now, we don't have the dequeue method. Instead, we have the try dequeue method. And like the other try methods, it returns a Boolean value, true if it was successful, false if not, but it will remove the first item from the collection, just like the normal dequeue method, and it too accepts an out parameter. So we have try dequeue. Since we already have our first variable, we'll just use that there. So once again, we would use the try dequeue method with an if statement, just like we did with the try peek method. But other than that, it's just another queue. Now, of course, this is useful only for multi-threaded applications, and then only if you plan on using the queue across multiple threads. A normal queue is still the way to go if you plan on using it with just one thread. So that's the queue class. The stack is also going to be very similar to a normal stack. We have a push method so that we can push items into the collection. So let's push hello. We will also push world. But there's another method that we can use to push a range of values, and that's called push range. And it simply accepts an array of items. So let's do that. Let's create a new array, and it's going to have foo and bar as elements within this array. So at this point in time, we have 4 items in our stack. Now we don't have the peek method. Instead, we have the try peek method. This is just like the peek method, except that it returns a Boolean value, just like the try peek method for the queue. It accepts an out parameter, so let's do out first. So if try peek was successful, then we have the first item value within the first variable. And there's also the try-pop method, which accepts an out parameter, so we will use first once again. But then there's a try-pop range, and it will fill an existing array with the items from the stack. So if we have an array with 3 elements, it's going to take the first 3 items from the stack and put those into that array. So let's just do that. We will create an array. This will be a new string array with 3 elements, and we will pass this array to the try-pop range method. It's going to take the first 3 items off of the stack and put them into the array. But of course, that's only if it returns true. If it returns false, then array is not going to have any items inside of it. So with the exception of the push range and the try-pop range methods, the concurrent stack is a lot like a normal stack. And really, I'm kind of surprised we don't have a push range and a pop range method in the stack. Those seem like those would be very useful methods. So now we have the ConcurrentBag collection. Now, a bag is just a collection of items. You add items to the bag and you take them out. It's kind of like a last in, first out, but it's not guaranteed to be in that order. And a bag can also have duplicate values. So unlike the stack or the queue, where it's just a collection of unique values, the bag is not. So let's add a few items to our bag. You simply call the add method and you add the item that you want to add to that collection. So let's do hello and world, since that's what we did with the other collections. The bag has a try peek method, and that's just like the other collections. It will try and peek at the first item in the collection, which is usually the last item that was added. This is an out parameter, so we'll just say out first. And then there's a method called try-take. So we add an item to the bag, and then we take an item from the bag. This is a lot like the try-pop method. It's going to take the most recently added item from the collection and return it in the out parameter. So we will use our first variable once again. But as far as the bag is concerned, that's it. It is a very simple collection. Now, once again, I have to stress that these collections are used for multi-threaded applications. Do not use them for single-threaded processing, because they don't perform as well as their non-concurrent versions. The IEnumerable interface is very important for collections, because that is what essentially determines what you can and cannot use with the for each loop. However, this interface doesn't perform the actual work. That falls to the IEnumerator interface. And as you can see from the IEnumerable interface, there is a method called getEnumerator, which returns an IEnumerator. So let's look at that definition, because this is where all of the magic happens. So we have 3 things with this interface. We have current, which is the current object in the collection. Then there's a method called moveNext that moves to the next item in the collection. And then there's the reset, which resets the position of the enumerator. So basically the process goes like this. When you use a for each loop over a collection, the getEnumerator method is called. It returns the IEnumerator of that collection, and then it calls the moveNext method. That's going to move the position to the first item in the collection, and that item is going to be referenced by the current object. And then for each iteration of the for each loop, the moveNext method is going to be called, and then it will go to the next object in the collection, which would be the current object. And it will do this until the end of the collection, or at least until you break out of the for each loop. And if you happen to use the for each loop again, then it will call the getEnumerator method to retrieve the enumerator, and that whole process starts again. Now, this is the original interface that came with the .NET framework in version 1. And in version 2, we got a generic version. It is simply the same thing, except that it is strongly typed. You can see that it implements iDisposable, and it also implements the original IEnumerator. The only difference here is current. It is now of type T as opposed to just an object. Now, the interesting thing is this iDisposable interface. That is something that we don't see in the original IEnumerator interface. But most collections have just an empty dispose method. because most collections don't have any external resources that it needs to dispose of. However, if you're going to write your own custom enumerator of T, then you will need to implement the iDisposable interface, and if you have any resources that you need to dispose of, you will need to dispose of them there. Now, implementing your own enumerator used to be very difficult, at least until C# and .NET version 2. Now it is very easy to implement an enumerator, but we won't get into that in this video. Instead, we're going to just manually enumerate over a collection. And it doesn't matter what collection it is, as long as it's a collection. So let's go with a list, because lists are easy to work with. We'll just make this a list of string, and let's initialize this list with a few values. It really doesn't matter what they are. So let's just have some random words like hello, world. Let's also have some cake, because cake makes everything better, as well as pie. So those are going to be our values inside of this collection. And if we are going to manually enumerate over this collection, the first thing we want to do is get the enumerator. So we will call the getEnumerator method. Now this particular method returns a type of enumerator. If we view the definition of this method, we see that it returns enumerator. This is actually a child type of list of T. It's a struct that implements the IEnumerator of T, iDisposable, and IEnumerator interfaces. Now you can see that there are three members here. There is the current value or object, there is the dispose method, and then there is the move next. Now there's not a reset method that we saw with the IEnumerator interface, but that's okay, because if we were to accurately emulate a for each loop, we will essentially be disposing of the enumerator whenever we exit the for each loop. So we can go back to our code, and we can, first of all, add a using statement here because we want to dispose of this. So using our enumerator, we will then enumerate over the collection. Now we have to move next because right now we haven't done anything as far as enumerating over the collection. So if we try to access the current property, we are going to get an exception. So the move next method returns a Boolean value. That means we can use it with a while loop, and we will simply call move next. And then inside of this loop, we will do something with our current value. So let's write something to the console with the writeLine method, and we will use e.current to get that value. And then after we exit our loop and exit the using statement, our enumerator is disposed of. And then let's make a call to the readKey method, so that the console window will stay open whenever I press F5. So here we see the contents of that collection: hello, world, cake, and pie. And that is the essence of manually enumerating over a collection. It is the IEnumerator interface that makes it easy to enumerate over a collection, whether if we are doing so manually, like we did here, or if we are using the much easier to use for each loop. Without it, we would have a more difficult time performing this seemingly simple task. The IEnumerator interface is very important because it contains the state of a collection's enumeration. However, an enumerator was notoriously difficult to write. Not only did you have to create a new data type, but then you would have to implement the move next method, which wasn't always a simple task to do. In fact, a lot of developers did not relish the thought of having to write their own custom enumerators. However, in the second version of C#, we got this keyword called yield, which took all of the complication out of writing an enumerator. In fact, writing enumerators are a thing of the past because this yield statement makes it completely obsolete. Now, when you use the yield statement, you are essentially creating a state machine. And there are two ways to use the yield statement, which we will talk about here in a few moments. Let's first of all write a method that is going to return an IEnumerable of int. And inside of this method, we are going to use the yield statement to yield values. Let's just call this getValues, and then we will start using the yield statement. Now, the first way to use the yield statement is yield return and then whatever it is that we want to return. So since we are returning integer values, let's just count from 1 to 5. So let's copy and paste a few lines and let's change the values. So we have yield return and then our value. The second way to use the yield statement is yield break, which we will talk about in a few moments. Let's first of all see what happens whenever we use this getValues method. Now this is returning an IEnumerable of int, but notice that we don't have any type of collection inside of this method. We are simply yielding the values one at a time. So inside of our main method, let's use a for each. Let's say var value in getValues, and we will write each value to the console. So we will use the writeLine method, and we will pass in value there. Let's also add a call to one of the read methods, just so that the console will stay open. I'm going to use read key, and then let's press F5 to see this in action. So we see our values, 1, 2, 3, 4, and 5. But let's change this to manually enumerate over this IEnumerable event. So instead of using the for each loop, we are going to, first of all, retrieve the enumerator. So let's create a variable called e. We will say get values, and this is going to have a method called getEnumerator, because the getValues method returns an IEnumerable event, and the IEnumerable interface has the getEnumerator method. So we retrieve that enumerator, then we have a while loop, so while move next, and then we will write our value to the console. So let's just copy that line, but instead of the value identifier here, we are going to use e.current. Now this is what happens whenever we call the move next method. It's going to execute all of the code inside of the getValues method until it reaches a yield statement. So for the first iteration of the while loop, it's going to pass control to the getValues method. It's going to execute all of the code until the first yield statement. Now, of course, we don't have any other code inside of this method, but if we did, that would execute, then it would return the value of 1, and then the execution of getValues would stop right here where we yield return 1, and it would wait until the move next method is called again. Then control will fall back to the getValues method. All of the code will execute until it reaches the next yield statement, which is yield return 2. Then it will return that value. Execution will stop for getValues, and then it will fall back to the while loop, which we'll call move next once again. And then the same pattern happens. Execution goes back to getValues. All the code executes until the next yield statement, and then it returns the value of 3. So let's actually demonstrate this. Let's create a variable called value. Let's initialize that with the value of 1. And then we will just return value here. But in between each of these calls, we are going to increment value. So we will have value plus plus, and we will do the same thing there, and between each yield statement. So whenever we run this again, we are going to see the same results that we had before, except that we are no longer returning literal values. So let's run. We will see 1, 2, 3, 4, and 5 in the console. So for all intents and purposes, we have implemented our own enumerator. Now, the yield break statement will exit our little state machine. So after the third iteration, let's do yield break. And if we run this again, we are going to see 1, 2, 3, and then nothing else, because we specified yield break inside of this method. That was essentially the end of our collection. And in fact, IntelliSense is warning us that if we hover over this green squiggly, it says that this is unreachable code, because we have essentially ended the method with the yield break. Now, there are a few rules that we have to follow as to where we cannot use the yield statement. First, we cannot use them inside of anonymous methods. We can also not use them inside of methods that contain unsafe blocks. And we can also not use them inside of methods that have ref or out parameters. But other than that, we can use them just about anywhere that returns an IEnumerable. So that means inside of a method or inside of the get accessor of a property. So the yield statement was a very welcome addition to C#. Most developers rejoiced because it makes it very easy to create an enumerator. Implementing the IEnumerable interface really depends upon your particular circumstance. And I know that that sounds like a cop-out, but it's true, because the whole point of the IEnumerable interface is to get the enumerator. So really it depends upon what you want to enumerate as to how you implement IEnumerable. And we're going to look at a few examples in this video. We're going to start with a simple class that is going to return 3 hard-coded values. Now, this isn't something that we would normally do, but it's a good place to start as far as examples are concerned. So let's just call this class 1. Let's make it public. And then we want to implement IEnumerable. And let's use the generic IEnumerable. And let's do IEnumerable of string. Let's hit Control Dot and enter to implement that interface. And then we see that we have to implement 2 getEnumerator methods. Now, the reason why we see 2 methods here is because we have 2 interfaces that we have to implement. Not only do we have to implement IEnumerable of t, but remember that IEnumerable of t also implements IEnumerable. So we have 2 getEnumerator methods, but one of them we can cheat on. For the non-generic version, we can simply return getEnumerator, and then we're done. This is going to call the generic getEnumerator method, and then, well, there's nothing else to do there. But inside of the generic method, that's where our code is going to be. But in this case, we are simply going to yield return and then 3 string values. So let's do yield return world and hello, although hello probably should have been first. And then we need some other string value. Let's just do foo. And so at the most basic level, this is all that you have to do. You implement your 2 getEnumerator methods. One of those does the actual work. So let's actually change this up so it's something a little more useful. Let's make this a person class. Let's go into implement IEnumerable of string, and then let's have 3 properties. We will have the first name property. Let's also have a middle name property, and then a last name. And then the getEnumerator method is simply going to enumerate over these 3 values. So we will start with first name followed by middle, and then last. Now, this isn't very useful still, but it's a little more useful than what it was before. So if we yield return first name, yield return middle name, and then yield return last name, then we get all 3 of those values by simply enumerating over this object. Now, I typically wouldn't write code like this, where I have a non-collection class implementing IEnumerable. The reason being because whenever I see IEnumerable, I immediately think of a collection, and a person class is definitely not a collection. Now, there's no rule that says that only collections have to implement IEnumerable, because if we were to compile this, create a person object, and then enumerate over that object, it would work just fine. And I'm sure that there are some very edge cases where something like this would make sense. However, for the most part, I would say that if you're going to implement IEnumerable, it needs to be on a collection. So let's write a collection. In fact, this is going to be a person collection, but it's going to be a very simple person collection. So let's just call it simple person collection. And there are many different ways that you can write a collection. Now, at the very least, it needs to implement IEnumerable. So let's do IEnumerable of person. But we could also take this a step further and make this an IList a person. We could also implement ICollection and so on and so forth. Now, if you take that approach, you're going to have a lot of methods that you have to implement, and it can be very tedious. So for the sake of simplicity, we're just going to implement IEnumerable a person. Let's go ahead and implement that interface. And this is going to have an internal collection, one that we will use to store all of our person objects. So private read only, we will make this a list of person, and let's just call it underscore people, and we will go ahead and call that constructor. Now, we need some methods in order to add and remove person objects from this collection. We're going to keep things simple, and we're just going to have a method called add. So public void add, we will accept a person object, and then we will simply use the add method on our internal collection to add that person. Now, this is the type of thing that you would do if you were implementing the other interfaces like iCollection and iList. If you had an internal collection, you would just simply use the properties and methods of that to do the actual work. So everything within our simple person collection would actually just wrap around this internal collection. Now, this gives you a lot of flexibility because you can come in here and say, If the person's first name is equal to John, then I only want to add those people to this collection. And you can do things like that if you wanted to. But of course, it's a lot of extra code that you have to write because there are a lot of members that you have to implement with the iList and iCollection interfaces. However, the general rule of thumb is if you want a lot of flexibility, you have to write a lot of extra code. But in our case, we are just going to leave this as is. We will be able to add person objects to this collection, and then we want to iterate over them. Well, once again, we are going to cheat a little bit, and in the non-generic version of getEnumerator, we're simply going to return getEnumerator. And then for the generic getEnumerator method, we want to do one of two things. We want to actually iterate over our internal collection, which we could do with a for each loop. So we can say, for each person in underscore people, then we will yield return that person. That's one way of doing it. Or we could take the easy way out and simply say underscore people dot get enumerator, although we do have to return that. Either way, we are going to get an IEnumerator to enumerate over the collection. Now, the other implementation using a for each loop gives us, once again, more flexibility. So if for some reason we only wanted to provide the person objects that meet a certain criteria, we could do that here. However, I will say that that isn't the best way of approaching that particular solution. We are enumerating over a collection, and we want that enumeration to be an accurate representation of the collection. So if we wanted to do any type of filtering, we would really need to do that whenever we add objects to the collection. Now, the last approach that we're going to look at is probably the easiest, and it relies upon a concrete collection implementation in order to provide the enumerator. So let's call this person collection, and we are simply going to inherit one of the concrete collection classes like list, or we could do collection. So let's just do collection of person. And we will need to add a using statement for the system collections object model namespace. And in this case, we don't have to do anything because the IEnumerable interface is automatically implemented by the collection of T class. So when it comes to implementing the IEnumerable interface, think about what it is that you want to enumerate, because that is going to determine how you implement the IEnumerable interface. Well, here we are at the end of the course. Before I leave you, let me offer you some tips on some of the topics we covered. First of all, attributes are an extremely powerful feature. They allow us to not only add metadata to our code, but they can also provide very useful functionality. As you are writing your applications, look for areas where it makes sense to use attributes. A perfect example are the wide array of attributes used in the ASP.NET MVC framework. There are just too many to list, but take a look at how the HTTP GET and HTTP POST attributes are used to handle and execute method overrides. Also look at the validation attributes in the System Component Model Data Annotations namespace. Not only do they provide metadata for our code, but they can also validate the properties they are associated with. Now, collections. As you learned, there are many collections in the .NET framework, and each one exists for a very specific purpose. Speaking from experience, it's very easy to fall into the trap of using only lists or dictionaries. Now, both of those types of collections are very common, and they are extremely useful in a variety of situations. But always ask yourself if they are the best collection for the task at hand. If you need the functionality of a queue, don't use a list. Use a queue. If you need a dictionary, but the standard dictionary doesn't quite meet your particular needs, look at the other dictionary type classes, like the KeyedCollection. I'll admit that it can be daunting because, as I mentioned, there are a lot of collections, but it does get easier the more you do it. Thanks for watching.